just a quick refresher in regards to inequalities. If you have either less than or greater than, you're going to be using a dashed line. If you have a less than or equal to or a greater than or equal to, meaning there's a line underneath the inequality, it's going to be a solid line. In regards to shading, above or below, if you have less than or equal to, you will be shading below. And if you have greater than or equal to, you're going to be shading above. So for number 16, which point on the graph satisfies the conditions x is less than 2.5 and y is greater than 3.5? What we want to remember is that if I have x and some sort of inequality or equal sign to a number, that's a vertical line. So knowing that, I'm going to have a vertical line when x is 2.5. So that's about right here. And it says less than, so I'm going to shade technically below, but because it is a vertical line, I neither have above nor below. So in this case, you're going to shade towards the negatives. So I know my solution is going to be somewhere in this area, but I have to take into consideration the next parameter. Over here, we have y is greater than 3.5. So then again, if you have y, an inequality or an equal sign, and then a number, that's going to be a horizontal line. And in this case, that horizontal line is at 3.5, right about here. It is a dashed line. And that says greater than. So greater, you're going to shade above. So the point that satisfies both of these conditions is the point where the shaded regions overlap, which happens to be this one right here, point S. Now for number 17, it says the origin, meaning the point 0, 0, is in the solution set of the inequality x plus 2y is less than or equal to negative 14. We want to determine if this is true or false. So in the origin, we have x is equal to 0 and y is equal to 0. What you can do is you can either graph this and then find the solution that way, see if it's true or not, or you can just do this algebraically. In place of x, you're going to put a 0. And in place of y, you're also going to put a 0. 2 times 0. So when you evaluate that, anything times 0 is 0. So that's 0 plus 0, which is 0. And the final statement would be 0 is less than or equal to negative 14, which is not a true statement. 0 is not a value that is less than or equal to negative 14. Therefore, the origin is not a part of the solution. Number 18, which equation or inequality represents the graphs? So I have 3 different graphs and these are all multiple choice. So again, we can use the process of elimination to increase your chances of selecting the correct answer. So looking at this graph, I can see that this is a solid line that is shaded above. So that means I am going to be using this greater than or equal to because it is a solid line using the greater than or equal to and it's shaded above greater. So that means I can eliminate B and C because right away I can see that this is an equal sign which is not greater than or equal to, and this one is a less than or equal to, which is again not greater than or equal to. So then you're down to these 2 choices. Now we need to take into consideration the different slopes. Which slope matches? And if you can see here, if you choose points at each crosshairs, the rise over run is 1 over 2, meaning I rose 1 point and I ran 2 points. So the slope needs to be 1/2. That eliminates A, therefore your answer is D. Now for this next one, it's hard to see, but this is a dashed line. So that means you're going to have an inequality that does not have a line underneath it. So you can automatically eliminate A and C, and it's shaded below. If you take your y-intercept and you see that the area below it is shaded, that means it's shaded below. Use that as a reference point. So the only one that signifies that it's shaded below is B, less than. Less than says that it's going to be shaded below. So for this last graph, I can see that it is a solid line, but all of these designate a solid line, except I have a shaded region. That eliminates option B because this only represents a line with no shading. Now we need to compare the slopes and the y-intercepts. Here I see my y-intercepts, they're the same. I need to look closely at my differing slopes again and see which one is true. So going back to your graph, you're going to find 2 points at a crosshairs and find the rise over run. So in this case, from this point to this point, they dropped 3 units, so that's a -3, and then they ran to the right 2. So that's your slope, and the only one that matches that is C. So for number 19, it says, which of the following ordered pairs is in the solution set of y is greater than 1/2 x plus 3? Well, just looking at this inequality, this is greater than, meaning I'm going to shade above. Also, because there's not a line underneath it, I'm going to be using a dashed line. Because this is already solved for y, I can just go ahead and plot it. So plot your y-intercept at 3, and then do your rise over run. They went up 1 and then ran to the right 2. So from your y-intercept, you're going to go up 1 over 2 and keep going until you run out of room.
And after that, you do the opposite to complete your line.
And remember, guys, do not connect the dots because this is a dashed line. And then we shaded above. So I'm just going to lightly shade so we can kind of see. And the question is asking which of the following ordered pairs is in the solution, meaning which one of these points lies in the shaded region. That's what it means by an ordered pair being a solution. So let's check all of these. -7, -2, that's about right here. This is in the shaded region, but let's check the other ones just in case. 5, 7. 5, 7 is about right here. This is also in the solution. Option C says -2, 1. Aha! This one is not in the shaded region, therefore this is not a part of my solution. And then the last one is 4, 5. It's on the dashed line, and because it's on the dashed line, it is not included. So, but if it was a solid line, and we were looking at that point, it would be a part of the solution. But in this case, because it is a dashed line, it is not included. So your answers are A and B.
Actually, take another look at option A, -7 and -2. You go down, not up.
Oh. -7, -2. A is not part of your solution.
Sensei's very tired. Please don't hold it against her.
I'm sorry.
Okay, so based on that last problem, Sensei is very tired, so I'm going to take over for the next couple of questions. So for number 20, which inequality best describes the graph shown below? Okay, this problem is a bit of a special thing. I'm not going to pay attention to the equation on this graph at all. Biggest reason is that on the answer choices, it's all the same equation. So what we're looking for is simply which inequality matches the graph we see here. So what we can see about the graph is that it's a dashed line and that it is shaded below the graph. So basically, for the criteria of dashed and shaded below, what we want to see is a less than symbol without the equal sign. So, looking at our answer choices, considering just dashed, that will eliminate choices A and D because they contain that equal to symbol. And now, since we want it shaded below, we want that less than symbol. And we see that on choice C. That is our answer. In order to collect a bonus, Andrew must sell at least 150 cars during a month. In the third week of the month, Andrew started with a total of 95 car sales and sold 12 more cars during that week. Now it's asking which inequality describes how many cars, represented by C, that Andrew must sell during the last week of the month to earn his bonus. We're going to take all the parts that I underlined, which are the important parts of this question, and we're just going to try to construct our inequality. So, to earn his bonus, Andrew's going to have to sell at least 150 cars to earn it. So, 150 is our golden mark here. So, if he wants his bonus, he has to sell at least 150 or more. So it can be 150, at least 150 or greater. So I'll have that greater than symbol and equal to. Now, for the numbers that we do have, he sold at the start of the third week, he sold 95 cars plus 12 cars during that week. That will combine to 107. Now, he's going to have to make up a difference for the last week in order to make up that 150 car sale quota in order to earn his bonus. That number is earned by C. He's going to need that money, sales, plus the total that he has in order to reach the goal he has to make before the end of the month. So this is our inequality. And the answer choice that best matches that is answer choice D. For question 22, the solution set of the inequality 2x plus 3 less than 3x plus 5 were graphed on a set of coordinate axes, the graph would be, well, take a look at our inequality symbol here. Do you see any equal to symbol? I don't. So, anything with a solid in the answer choice is automatically taken off. But wait, we can actually narrow it down even further. You remember when you see x in an inequality, and when x can be represented by a number, x will take the shape of a vertical line on a graph. That will allow us to eliminate answer choice E. So now all we have to do now is take that inequality and solve for x and see what we have. So first, I'll subtract 2x here. That will cancel this out, leave us with x plus 5 is less than or greater than 3. I'm reading the inequality backwards, but hopefully you can at least see it here. Now, I'll subtract 5 here, cancel this. That'll be negative 2 is less than x. Or in other words, x is greater than negative 2. So, our x value is negative 2, it's shown here, but we just need to figure out which direction that x value is that the graph is going to be shaded in. So if x is greater than negative 2, it's going to be shaded to the right. Our answer choice for number 22 is D.
Because towards the right, those are the positive values. If you're shading towards the right, that's technically above. You're shading the higher values.
Yeah, just think about it. Numbers like 1, 2, 10, 100, 1 million, they're all x values that are greater than negative 2. For question 23, which inequality represents all real numbers greater than or equal to 3 and less than 7? We're going to come up with an unknown x value, but it's going to be greater than or equal to 3. But we're also going to have x be less than 7. It's all just how you read it from left to right. So with x greater than or equal to 3, where do we see our match? 3 greater than or equal to x? No. The answer choice A will not work. Answer choice B, 3 less than x, that will not work either. Answer choice C, 3 is less than x, again that will not work. Let's look at answer choice D. It says 3 is less than or equal to x, which is equivalent to the first thing we wrote down here. And it says x is less than 7. That fits both inequalities that we wrote up here, so our answer choice is D. Now for question 24, the football team wants to sell raffle tickets to raise at least $50,000 to attend the state tournament. To run the raffle team, that's enough.
So for this type of problem, we're going to set this up as if we're going to write our equation in y equals mx plus b format, where m is your slope or your rate, and b is your starting point. The starting point,
they start in the hole by 3,500.
And then the rate is $5 each. So after that, they earn $5 every ticket.
In terms of this problem, though, x would be replaced by t.
So they need to raise at least $50,000. So $50,000 represents the y value. So I'm going to put the 50,000 over here. Now comparing these two quantities, the amount that they earn versus the amount that they need to earn, they need to make at least the amount that they need to earn. That denotes this inequality, greater than or equal to. The amount that they earn needs to be more than the amount that they want to earn. They need to earn at least this amount. So they can earn equal to this amount or even more than that.
If they earn more, they can afford burgers instead of just pancakes or something.
So notice these answer choices, they are solved for t. So that means we're going to have to solve for t. So just like solving for an equation, add 3,500 to both sides. Now you're left with 5t is greater than or equal to 53,500 when you add those together. And then now to solve for t, you do the opposite operation. Divide both sides by 5. And then you're left with t is greater than or equal to 10,700, which matches letter C. Now for number 25, we're getting on to setting up systems of equations, which is the second part of your exam. Number 25 states, there are 9 books stacked on a shelf. The thickness of each book is either 1 inch or 2 inches. The height of the stack of 9 books is 14 inches. Which system of equations can be used to determine x, the number of 1-inch books in the stack, and y, the number of 2-inch thick books? We're going to have 2 different equations, one that corresponds with the number of books, and one that corresponds with the height. We have 2 totals. We have a total of 9 books, and we have a total of 14 inches. 9 books corresponds with the number of total books, and 14 inches corresponds with the height. So in terms of the number of books, the variables that they gave us, x represents the number of 1-inch books, and y represents the number of 2-inch books. If we have a total of 9 books, that means we take the number of 1-inch books, however many that is, plus the number of 2-inch books, however many that is, and then add it together, and you get 9. So we already designated this as x, so we can replace that with x. And we already designated this quantity with y, so we can replace it with y. So thus, x plus y is equal to 9, and that is your first equation for your system. So because this is multiple choice, you could start using the process of elimination. That right away eliminates f and g, because this says x plus y is 14. Same with this one, but we know x plus y to be 9. So now we're left with answer choices H and J. Well, the only difference between these two is the bottom equation. Here they have 1x plus 2y, but here they switched it. They have 2x plus 1y. So x represents the number of 1-inch books, and y represents the number of 2-inch books. The only ones that correspond with those numbers are letter H. X has a 1 next to it for 1 inch, and y has a 2 next to it for 2 inch. So your answer is H.
So for number 26, a school principal ordered 100 pizzas for a total of $1,255. Fatty. Cheese pizzas cost $11.50 each. Man, that's a lot. Pepperoni pizzas cost $13 each. These better be good pizzas. Which of the following systems of equations can be used to determine C, the number of cheese pizzas the principal ordered, and P, the number of pepperoni pizzas the principal ordered?
So we have 2 variables here, C and P. C for cheese, P for pepperoni. And we're given 2 numbers, 1150 and 13. That C is going to be linked with 1150, and that P is going to be linked with 13, because it tells us here cheese pizzas are 1150 each, pepperonis are 13. That'll come towards our system later. The thing about systems is that they'll often be comparing 2 certain sets of data. The first equation is almost always just going to compare it to the number of objects there are. It can be books, pizzas, pajamas, whatever. And the second one's usually going to be a measurement of some sort. 25, it's inches. Here, it's money. So, the school principal ordered 100 pizzas total. And if all he orders are cheese and pepperoni pizzas, it'll be C plus P. We'll have that total of 100. So, C, you can have with answer choice B with C minus P. That answer choice is automatically incorrect. D, same thing. That answer choice can be crossed out. Now, because cheese pizzas are $11.50 each, we can write that here, because we're starting to try to figure out how much it actually costs, but that total is written up here. And then pepperoni are 13 each, so we stick those 2 together. We don't put 13 with C or 11.50 with P. That's not how the problem gave it to us. So in total, $1,255. So we got to figure out which one matches this. 13C, no, that's wrong. 1150C plus 13P, that's correct. Answer choice for this problem is C. If a rectangle has a perimeter of 36 centimeters and its width is 4 centimeters less than its length. So what we have to do for these next set of problems is create a system of our own and define what the variables are. So for this problem, the variables are stated here in the problem. We have width, which we'll just represent with W because, well, width starts with W. Let's just keep things simple and straightforward. And length, which we'll just designate with L. Now, the rectangle has a perimeter of 36 centimeters. Well, how do we define perimeter of a rectangle? If you remember your basic geometry, the perimeter will be 2W plus 2L. Because if you'll remember, shape of a rectangle with its 4 sides, 2 width sides, 2 length sides. So W plus W, L plus L. All of that put together is the perimeter. And here it designates that the perimeter is 36 centimeters. So I'll write over here 2W plus 2L equals 36. That's our first equation. Now for the second half of this, it states that the width is 4 centimeters less than its length. If you do L, and it says 4 centimeters less. So to make up for that, we have to add 4 to W to get length. Width is almost always shorter than length. You can just use that as a rule of thumb. But you just have to make sure that it says so in the problem. So if it's 4 centimeters less, to make it balance, width plus 4. And this is our system.
What are you doing? Shush. You shall be punished.
No!
Number 28. Number 28 says the sum of two numbers is 36. Their difference is 6. So I don't know what these two numbers are, but we're going to designate them as x and y. X will be my first number, y will be my second number, whatever they may be. So the sum of two numbers is 36. So sum means to add. That means if I add these two numbers, whatever they are, their sum should be 36. So thus x plus y is equal to 36. Same thing here. Their difference, so meaning subtraction, is 6. So meaning if I take x and y and I find the difference between them, it will be 6. So that means x minus y is equal to 6. And there's your system. Again, for this test, you won't have to solve them just yet, but in the next unit we will be solving it. But for now, just know how to set these up. For number 29, here Mary has 18 total coins with a total value of $2.85. If the coins are either dimes and quarters, how many of each type of coins does Mary have? Alright, so let's denote our variables x and y. I'm going to let x be my number of dimes and y be my number of quarters. So I'm going to have two different types of equations, one involving the number of coins and one involving the actual value of them. However many dimes we have plus however many quarters we have, it needs to be a total of 18 coins. So that's simply x plus y is equal to 18. Because again, however many dimes you have x plus however many quarters you have y needs to be equal to 18 total coins. This has nothing to do with the price, so please don't say, oh, you have to multiply it by 0.10 or oh, you have to multiply it by 0.25, because we're not dealing with the value just yet, just the number of coins. Alright, now we can deal with the value. The total value is $2.85. Now, the value of dimes in dollar format, that's 0.10. And the value of a quarter would be 0.25. 0.10 corresponds with the number of dimes x. So to find the dollar value for however many dimes x that Mary has, you're going to multiply 0.10 by x to get that dollar value. But you also have to take into account dollar value of however many quarters she has. So you're also going to add 0.25 times y.
And there's your system of equations.
Last one, number 30. This one's a little more complicated, but anytime you're dealing with perimeters or any type of geometric figure, the best strategy here is to draw a picture to make sense of it. So it says here the sum, meaning addition, of the perimeters of two different squares is 32 centimeters. And I've got two different squares, so I'm going to draw two different squares. Here's my first square, and here's my other square. Squares mean that all sides are the same length. It also says that the difference between their perimeters is 8 centimeters. So if x represents the side length of the larger square, so here's my larger square, I'm going to say that this is x. And because one side of the square is x, that means all of the sides are going to be x. And the y represents the side length of the smaller square, so same thing over here, but for y. Write two equations to represent the information in the problem. Alright, so let's reason this out. The perimeter of this square, of this big square right here, should be x plus x plus x plus x, or just 4 times x. The perimeter of the smaller square would be y plus y plus y plus y, which is just 4y. So it says here that the sum of the perimeters, so adding these two up together, is 32. So my first equation would be 4y plus 4x is equal to 32. And that's your first equation, based off of the sum of the perimeters. And now here it says the difference between their perimeters is 8 centimeters. Now, because I know that the perimeter of the larger square will be larger than the perimeter of the smaller square, I'm going to put that one first so that I don't get a negative number. So if I take the difference of those, that would be 4x minus 4y. Their difference is 8 centimeters. And those are your two equations. Now the order for these two didn't matter because addition is commutative, meaning 3 plus 4 is the same thing as 4 plus 3. Order doesn't matter. But in the case of subtraction, subtraction is not commutative, meaning the order does matter. So for example, 3 minus 4 is not the same thing as 4 minus 3. So we do want to take into account that if I have a positive number for my difference, that means I need to subtract the smaller from the larger.